Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Devin. Hey, thanks for joining us, everybody. Excitement.
And in the studio with us, we have Val. And Val, if somebody wants to get a hold of us, what do they need to do?
For math homework, help call in Bakersfield 636-4357, toll free 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, and Twitter.
And YouTube. There's always another one always lurking out there. So nicely done there, Valeria. So let everybody know where you go to school and what grade you're in.
I go to Bill Williams, and I'm in 6th grade.
So a pioneer. And how long have you been a pioneer?
Well, I've been a lifelong pioneer.
So you've been there since kindergarten?
Yeah.
All right. So you've done all of your schooling there. What do you look forward to most when you go to junior high? Because you're going to be going to a whole new school now.
I'm looking forward to like the events that will happen and the field trips maybe.
Okay, so it's going to be a lot of fun. A lot of new people you're going to meet, a lot of new teachers and stuff like that. All going to be exciting. But you know what else is exciting?
What?
The first problem you're going to do today. So you and Devin over to the board. Here we go.
That's right. We're going to do this. Let's go ahead.
All right.
Get started.
Here's the first problem. 6x plus 3, open parentheses, x plus 7, close parentheses, is equal to negative 15.
We have so much going on here with this expression, with this equation. We've got terms. We've got distributive property. We've got integers in the negative realm. There's so much happening here. How would you start off with something like this?
I try getting rid of the parentheses.
So this distributive component, this is the thing that really stands out as far as what you want to work with first. And that's going to unlock a lot of other things with this expression. So let's go ahead and distribute. How would you do so?
I'd rewrite it. I'd rewrite, and then I'd multiply.
Okay, so you're going to multiply here. You're going to keep that 6x. We're not doing anything with that yet.
3x. And then positive 21.
So you multiply the 3, which was positive, in with the 7, which is also positive, to get a positive 21. Now, are these just kind of next to each other? Is there anything else we need to bring down here as part of this between the 6x and the 3 and what you worked with here?
I think we need to bring this down.
Okay. And we're just adding this 6x to what we distributed out here, right? So we want to make sure we bring those operation sounds down. Now we have 2 x terms, and we have 2 whole number integer terms. So what can we do next with this?
We can bring them together, which would make 9x.
We're combining like terms to have 9x, and we still have that plus 21 here, it looks like. But is there something we want to do with that?
You could subtract 21 to get rid of it.
So let's subtract 21 from both sides of the equation here, right? So we have to do negative 15 minus 21.
This one cancels out.
That leaves us with 9x on this side.
And then that'd be 36.
Now, we went further into negative territory. If this was a number line, negative 15 is here. We're subtracting 21 from that. So yeah, it would be negative 36. But you were able to calculate that pretty quickly. How did you get to negative 36 just by looking at these two terms here?
Because, you know, more negative makes more negative.
So it's because you're subtracting a value from a negative, that puts you into further negative territory. So you just added the absolute value of those two integers together to get to negative 36. Okay, so we have 9x equals 36. What's our next and possibly final step here?
You could divide it.
So we're going to divide here. It looks like we have a term on both sides. What did we end up dividing both sides by here?
9.
So you're going to divide 9x by 9 and negative 36 by 9 to get us to x equals
4.
Now, is this going to be a negative 4? Now, we have a value for x that would satisfy this equation. How would we go about checking to make sure that x truly does equal negative 4 here?
You'd put negative 4 here.
Okay, so you plug in, wherever you find x, you want to plug in negative 4 for some of these terms. So we would have 6 times negative 4, which would be
Negative 24.
negative 24. I'm just going to kind of pop it over here into the corner so we know we have our check work. Now we also have, curse of the gems. You may have heard this as PEMDAS, but are you familiar with referring to order of operation as gems? It's the idea that instead of parentheses, we take grouping symbols, and then we have exponents, and then we can multiply and divide, and then we can add or subtract. Now, we have parentheses here. You distributed that 3 first when we first worked through this. Could you do that still here, or would you want to do the parentheses first?
You could do the parentheses first, but I prefer to distribute it.
Let's distribute here and see what happens. We have a positive 3 times negative 4. What would that be?
Negative 1.
Well, we have a multiplication here, right? We're not simply just adding these. If we're distributing, even though this is an integer here for the negative 4, it'd be negative 12. Now we have positive 3 times positive 7, and we kind of already did that work here, which makes it nice.
Yeah.
Positive 21. And we're going to say that all this should equal negative 15. So we have 3 values here that we want to see whether or not we can actually combine them together to get to this point. How would you combine these 3 integers?
You would add them because more negative equals more negative.
So you're going to go from negative 24 and go 12 further on the number line to the left. So this would be negative 36 plus 21. And what does that get us on a number line? We go negative 36, we go to the right 21.
It make you go higher?
Yeah, so we're getting closer to 0, and that brings us to, and we could probably just subtract when we have different signs here. We have a negative and a positive. So 36 minus 21 is 15, but since it starts off further negative, we know that this equals
negative 15.
So x equals negative 4 checks us out. Nicely done.
There you go.
Good
Nicely
work.
done with that first problem. Hey, do remember we have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. And time now for today's Math in the News. All right, so today's Math in the News has to do with something that just happened over the last weekend, dealing with time. Are you aware of what happened last weekend, this just past weekend, with time?
No.
You don't remember? Did you have to do anything with any of your clocks in your house?
Oh, that daylight saving.
The
Daylight
savings time?
Yeah, it ended.
And what did you have to do?
You had to put it an hour behind.
Right, so you had to fall back an hour, right?
Yeah.
So take a look at, we've got a couple of different clocks up here. Do any of these look familiar to you, like you've used any of them before? Or seen any of them?
This one.
The one in the middle up on the top?
Yeah.
Our first clock.
Yeah, there you go. Now, do you remember when you first used that?
I think around in kindergarten.
Probably in
You said
kindergarten.
5th grade, we would have a lot of questions.
Well, they could still use it in 5th grade, but not the
You could.
first time.
Be a
So a
big
couple of
watch.
different clocks we've got right there. So this is dealing with AM and PM. We're going to talk a little bit about the difference between those. So the term we associate with morning, AM, is an abbreviation for antemeridium, meaning before midday. PM is post-meridium, meaning after midday. So we can see that we've got a timeline, and we've got AM and PM on there. Now, you're familiar, Val, with AM and PM, right?
Yeah,
So right now, it is 4:10. Is it AM or PM?
it is PM.
It is PM, right? Because it's after midday, all right? So this is what you're going to be working on. So here we have a page of elapsed time number line. And when you see the first one, they went from 2:35 p.m. to 4:10 p.m. And there are a variety of ways to solve this problem, to find out how much time has elapsed. So what they did first is they went from 2:35 to the next whole hour, which was 3 o'clock, found it was 25 minutes. Then they went to the next hour, 4 o'clock, and then added 10 minutes, so they can see that it was in total 1 hour and 35 minutes. So here's the first problem that you guys are going to work on. So we have 11:55 a.m. to 1:20 p.m. So let me just write this down because we are going to go to the other screen.
So when you see the distance here between these two times, 11:55 a.m. and 1:20 p.m., and you have to find out how much time exists between those 2 points, what is your strategy? Do you try to count by minutes first? Do you try to get to a friendly hour? Or do you just start jumping up by hours?
I try to get to a friendly hour, which I know it'd be easier to find out the time by.
So let's try this, Devin. See if you can just write right on the side of that or on that, and we'll see if that works. If
Live
not, we'll go to
television,
the other
here we
page.
go. We got it.
There we
Okay,
go.
so
All right.
if this was your friendly time at 11:55 a.m., what would be the closest friendly hour to that going forward in time?
12.
12. So, a couple of things to keep in mind here. This is going to be 12. Is this going to, what kind of 12 o'clock is this? Is this going to be AM or PM?
PM.
Yeah, because once we get to 12 o'clock, we're basically starting at the beginning of a 12-hour cycle again. So we're going from 12 a.m. to 12 p.m. From 12 p.m., what would be the next friendly hour?
1 p.m.
1 p.m. And from there, what could we jump to?
We could jump 20 minutes ahead.
Yeah, so we have our 1:20 p.m. All right, so we have these gaps here. We have these splits that we can figure out distances between. We know that this is 1 hour, right? So let me just go ahead and kind of store this on the side here. I have 1 hour. I have these smaller pieces here, and we want to make sure we're clear on what they represent. So the time between 11:55 a.m. and 12 p.m. represents what?
5 minutes.
5 minutes. I'm going to go ahead and keep the minutes units separate over there so we can add them together, so we can keep them like. Now we have 1 p.m. to 1:20 p.m. What is the distance in time? What's the elapsed time between those two?
20 minutes.
20 minutes. Okay. So, how many hours do we have?
1 hour.
And how many minutes do we have?
25 minutes.
25 minutes. Organizing it like this makes it easy to organize and see lined up so we can combine them. So, the elapsed time from 11:55 a.m. to 1:20 p.m. was 1 hour and 25 minutes. I think that's an excellent way of thinking about things, and I think you did great there.
Nicely done. Now let's go on to the last problem. So 6:15 p.m. to 9:10 p.m.
I'm going to go ahead and let you work this off. However, I'm going to lay in a challenge to you. Instead of jumping to a friendly hour first, I want to see if you can approach this by jumping by full hours until you can't anymore. So starting at our start time at 6:15, let's see how many hours we can jump ahead and see what happens.
You can jump at 2 hours.
So let's take a big 2-hour jump here. From 6:15 p.m., we jump 2 hours to 8:15 p.m. Now, what's going to happen if we try to jump 1 more hour?
You will have an extra 5 minutes.
Oh, so we're going past 9:10 here, right? Because that's going to land us at 9:15. If we have 1 more hour, we land at 9:15. But you said something interesting. It's going to take us 5 minutes past it. So what could we do with that last hour?
You can You can subtract the extra minutes
Sure.
because there's 60 minutes in an hour. You can subtract 15 from it.
Well, are we subtracting 15 minutes, or we're going to 9 from 9, 10, 15 to 9, 10, right?
She's going to get it to 9, I think, first.
Ooh.
Then add the 10.
Okay. Okay. Let me keep up here. All right.
5. So you need 45 minutes. 2 hours
Sure.
and 45 minutes.
So you went back 15 minutes to get to 9 o'clock. And so in order to get to 9:10, how many more minutes do we need to add?
10.
10 more minutes. So we have 2 hours, 45 minutes, 10 minutes, which would be what?
Would be 2 hours and 55 minutes.
2 hours and 55 minutes. Now, here's another way we could have approached that. We realized we were at 3 hours at 9:15. We could have also just stepped back that 5 minutes. So we know that there's 60 minutes in an hour. What if we just took away 5 minutes?
And that'd be 55.
2 hours and 55 minutes. Gets us to the same place many different ways. It's one of the fun parts about elapsed time is that you travel along that timeline however you desire. I love time travel. Time travel, anything's possible. Everybody time traveled this past weekend. And we get to do it again in the spring, but it's not that much fun.
You're in the middle of time travel right now, but it's beautiful.
Let's do it. Everybody come with me on this ride.
How
Let's go.
everybody can solve a math problem in a number of different ways and still end up with the correct solution. Nicely done. That is today's Math in the News. All right. Lots of things we love to go out and check out on Do the Math when we go out and check out local businesses. Right now, something near and dear to all of us, our stomachs and the fine art of bread making.
Ooh.
All right.
Today we are at the Boys and Girls Club on Niles Street, and I am with Laura and Ian Journey with Baker's Outpost. How are you guys doing?
Good. How are you?
Can you kind of quickly tell us a little bit about yourselves?
Yeah, I'm Laura Journey. We started Baker's Outpost about 2 years ago, and
And what exactly is Baker's Outpost?
Baker's Outpost is a naturally leavened bread company. We focus on sourdoughs and fresh milled baked goods. We strive in old world traditions and minimal sugars and just bringing like nutritious, wholesome food back into people's diets.
And how did you get started with that?
When we moved here about 7-8 years ago from Canada, I was missing good bread, and so with 2 small kids and needing something new to fill my time, I slowly started producing bread more and more, and it just kind of became something we turned into a business.
And Ian, what do you do besides being an owner as well?
Not owner, an assistant to the baker, I clarify. I am, by day, I'm a mechanical engineer, so I design HVAC and plumbing systems, and then by night I am a delivery or whatever else needs to be done, yeah. But so actually the firm that I work for, Baskin Mechanical Engineers, we helped design this kitchen, so it's cool to actually be working, doing my passion with my wife in a kitchen that I didn't personally help with, but it's something that is near and dear to my heart because it's something I do on a regular basis.
And we're here quite a lot at the Boys and Girls Club. And last time we were here, this was just like the beginning phases.
Okay.
They hadn't even started. So it's really exciting to see. Can you kind of show us around with
Yes.
everything that's going on?
So the biggest difference compared to last time you were here, where it's more of a residential style kitchen, here you have fully commercial, what's called Type 1 grease hood with fire protection. So if an accident were to happen, there's sensors that would trigger the Ansel system to put the fire out. The other big upgrade is the walk-in refrigerator and freezer. So this gives the Boys and Girls Club ample space to store all of their goods.
And being at other businesses, this obviously is a business type of freezer, correct?
Yeah, this is what you would see at any of your favorite restaurants around town. Yeah.
So besides all of this over here, and then let's talk about the ovens, because those are all new as well.
Yeah, so the ovens, actually that's one thing I'll let Laura talk a little bit more about, but the ovens are just a typical convection oven that you would use for baking chicken or pies. Laura's actually kind of found a cheater way to replicate those old world wood-fired ovens to get the nice crusty bread that you'll see here in a little bit. So she was able to utilize generic ovens, to get the product that she
Laura,
wants.
can you kind of explain what you do with the ovens to get that?
Yeah, so when this whole frenzy of kind of sourdough baking came about, people started experimenting how to get the same effect of a like hearth baked loaf at home. And so the way they discovered that was through baking with like Dutch ovens or cast iron pots. So I bake out of 24 cast iron launch pots at a time that I load in and out of these ovens, and that's how I simulate what I would get out of a deck oven, which is what we will be using when we have our brick and mortar. So it's a flat top deck oven that has steam injection, that blocks and gives you that nice crispy crust.
So we are going to be seeing those in a little bit, right?
Yes.
Okay.
Yes, you will.
So you have some recipes for us, right? Okay, so when we come back, you're going to be showing us a little bit about your recipes,
Yes.
things you
Look
do.
forward to it.
All right, so we'll be back in just a little bit at the Boys and Girls Club, but back to you at the studio for now.
All right, thanks for that, Mary Lou, and I can tell you that is some fine bread.
You got your rye, you got your pumpernickel, you got your sourdough.
It's all good stuff,
Lay
I
it
can
out
tell you
there,
that.
cinnamon raisin. Let's do this.
We do have phone tutors available until 5:30 this afternoon. We've got Val, a 6th grade student from Williams Elementary in studio, working on equations, and time now to do another one. All right, over to the board.
You had that hand wave down, by the way. I hope everybody got a chance to see that. The perfect cup and turn, wonderful form.
6, open parentheses, x plus 2, close parentheses, minus 4x is equal to 48.
Now, the last time we did this problem, your first approach was to work with the distributive property. And we had an interesting conversation during the break about how might our approach change if we looked at the negative 4x first. So, if we wanted to start with this, what would we do with this?
We would try to get rid of 4x by adding it to both sides.
So we're going to try to move this x term by adding 4x to both sides. So when we do that, we've eliminated this here. Now left over here, we have 6x plus 2, and that's going to equal 48 plus 4x. Okay, so once we're here, this is when I think you're looking at our parentheses set here. So what would we do with that?
We multiply.
Now, I know a lot of people see this as like multiplying. Do you remember when you learned about multiplication, you got to play around with the area model a little bit, with those
Yeah.
rectangles? Did you know you can do that with distributive property too?
Really?
So we can work this out as a rectangle that would be 6 tall and break down x plus 2 as two separate parts, x and positive 2. So when we have these two terms, 6 times x
Is 6x?
and 6 times positive 2,
12?
what kind of 12 would it be?
Positive 12.
So 6x plus 12. 6x plus 12 is the same thing you would get if you were to do the distributive property. And that's going to be very helpful when there's more complex terms inside of that. But that area model does also apply to the distributive property. So we have 6x plus 12 equaling, well, why don't we try this here? We have 48 plus 4x. Is there another way we can maybe order that and arrange that so that there's a little bit of structure here? What could we do with how we write this?
We could add, try to add them.
Well, we could try to add these. Could we represent this by, think about the commutative property of addition. Could we switch these terms around? Could we represent this as 4x plus 48? It would be the same thing because we'd be able to maneuver those around. Now, we have 6x's over here, we have 4x's over here. what do you think would be a good way to leave x just on one side?
Eliminate this one.
Yeah, so we'll take 4x away from both sides. You do that side, I'll do it this side. What's left on your side? Nothing. What's left on my side?
2x.
Okay, so we have 2x. Now, I've got 12, you've got 48. What should we do to make sure at least one of us has some values on our side?
Divide?
Well, we could divide. I don't know if we divide, though, we have to divide everything here. Hey, why don't we try to take away 12 from both sides? Okay? I'll do that, and you do that on your side. I got nothing this time. Ha! Turnabout. Now you have 36. So it looks like 2x equals 36. So if 2x is 36, what does x have to equal?
It has to equal 18.
18, because 2x divided by 2, 36 divided by 2. So x equals 18. I can guarantee that if we plug 18 into this original problem here, we'll get equal values on both sides. Wonderful job. Wonderful job, Val.
And for doing such a wonderful job, you've got yourself
out.
a free meal, courtesy of your choice
Look
from
out!
Broken Yolk.
Oh, boy.
So, congratulations
You
on
all
that.
right? Those things get messy. Anything? We need a towel? Let's get a towel in here? No?
We'll be back
Good?
with more right after this.
It's all over.
Today we're at Kernville Elementary School, home of the Mountaineers, and we're here to Well, here we are at Kernville Elementary School with some 4th and 5th grade students. We were doing a little bit of adding and trying to get a low score with golf in our last game. And there are some numbers that seem to come up more often than not when you're rolling dice. Okay? Have you ever heard somebody say, my lucky number is 7? You've heard that? Why do you think people say their lucky number is 7? Why do you think?
Because when they play games, they usually get 7s.
Right, it seems like 7 comes up a lot, right? So they're like, oh, 7's my lucky number because it always seems to come up. We're going to see why. You ready? Okay. Here's what I want you to do. On your paper, I want you to draw a line across the top like that. Go down now, but leave a little bit up here. Okay? So now what we're going to do is we're going to label these and spread your numbers out. We're going to go 1, 2, 3, 4, 5, 6, right across the top. Now what I want you to do is in between each of those numbers, draw a line going down. Okay, it doesn't have to be perfectly straight. Just draw a line going down like that, in between each of the numbers. Now we're going to do the same thing going down the left-hand side. So I'm going to put 1, 2, 3, 4, 5, 6, all the way down. These are going to represent our 2 dice when we roll the dice. Okay? Now we need to finish this by going across with the lines between the numbers so that we have our chart looking like this. And we're going to see if 7 is a lucky number. Okay, and we're going to do it mathematically. We're going to prove whether it is or isn't. Okay? So if I roll a 1 and a 1, what will I get?
2.
So I'm going to put a 2 in there. If I roll a 1 and a 2, what do I get?
3.
3. A 1 and a 3?
4.
This is too easy, isn't it? All right, finish going across the top. Okay. Now we're going to go to the 2. If I add 2 and 1, what do I get?
3.
3. 2 and 2?
4.
You guys see the pattern? Keep it going. What do you think we're going to do on this row of 3?
3 plus 1.
So we're going to go 3 plus 1 is 4. So finish filling out the whole chart. And you'll notice that every time you go over and down 1, the numbers increase. Right? It's just a pattern, you just keep on going. All you're doing is making a chart, a graph of when you roll the 2 dice, what the sum will be when you add the two dice together. As you're filling it in, completing it, what I want you to do is I want you to look at your chart now, right? Find which number on the inside, okay? We're not counting these numbers, right? These are the two dice. We're looking at the sums inside. Find which number comes up the most. Hold on, give everybody a shot at it first. So on your graph, look and see which number comes up the most times. Which number do you think comes up the most?
7.
What did you find come up the most?
7.
Did you find the same thing? Mm-hmm. You too? You found 7 the most? Why do you think 7 comes up the most? Because it's lucky? Luck doesn't have anything to do with it, right? Why does 7 come up the most on this?
Because if every dice you roll, it can be 7, but if like you roll one and I want to keep, it can't be 1.
Right, because
So,
if somebody said, we're going to roll 2 dice, you get to pick a number. You should pick 7 because it comes up the most often, right? And if, let's say somebody goes, oh, 7's already taken. What number comes up the next most? 8 and 6, because it's on either side of 7. All right, you guys get the idea?
Yeah.
So you can take a look, you can mathematically prove that 7 comes up the most. That's why people think 7 is their lucky number. And that, a little bit more math with the 4th and 5th grade students at Kernville Elementary School.
Closer, 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 closer. Good job.
And a big thanks to the staff and students at Kernville Elementary School. Almost had that kid in that camera right there. We do have phone tutors available until 5:30. We've got Val in studio, but right now let's find out a little bit more about baking bread.
We are back at the Boys and Girls Club on Niles Street with Laura and Ian Journey from Baker's Outpost. And so now we're going to kind of go into your world of baking. And I love it how you have on your thing over there, it says bread is all about proportions. Can you kind of explain?
Yeah, so a baker's percentage is a way of breaking down proportions so that you can either scale up or down as you need. You can use baker's percentages not just with bread, but with all sorts of baked goods. In baker's percentages, the total weight of the flour is always at 100%, and all other ingredients are expressed in relation to this. So I just have like a little bit of a sample here. So if we needed 10 loaves at 960 grams each, which is what these are, a standard loaf that we do, our total dough weight would be 19,600 grams. From that, to figure out your flour, which was always at 100%, you would add up all of these ingredients. So you would take your water weight, your starter, your yeast, the salt, and the flour, add that up. So here you can add those all up and see you've got a total of 212. You take that 212 into the 100%, which gives you 0.47. So you take that number, multiply it by your total dough weight, which we figured out here was 19,600 grams, and that's going to give you your total weight here in flour grams, 9,245 grams. And from there, you use that number, just going down the list and multiplying to figure out your total dough weight.
Okay, Laura, so one of your vendors calls in to make an order. What do you do here? What calculations will you make?
So I would first off find out, so one of my vendors would be the Padre Hotel. They have a pretty standard loaf size. If they called and ordered, let's say 20 loaves, each of those loaves I make weigh 1,500 grams. So if you need 20 loaves total and each is going to be 1,500 grams, That's going to give you a total dough weight, which I abbreviate with TDW, is going to be 30,000 grams. So that's your total dough weight. From here, you need to figure out, flour is always 100%, so we know that. You need to figure out what you want your hydration to be at. I work with typically around 85% hydration. And then levain, which is your starter or your yeast, I work with roughly 25%. And my salt is 2%. So you're gonna take these up and add that up.
I noticed that. I was thinking that all of this had to equal 100%, but it doesn't.
Right, so that's the one confusing part, and some people get a little confused with, is that the flour is always 100%, but then your number that you use to add in is gonna equal more than 100%.
I could see how that's confusing.
Yeah, and so here, as you can see, we have the same total percent as we did on the board, because these are typically my ratios here. And so here you've got 212%. And so to figure out your flour weight, you're gonna take 30,000 and divide it by 212%. Divided by 212, which gives you 14,151 if you round up grams. So this is going to be your flour weight. So from there, to find out your hydration or your water weight, you take this number, multiply it by 85%.
So obviously there is a lot of math here with your percents and decimals too, right? Because you're having to change these percents to decimals.
So that would give you 12,028 grams of water. And then your levain. So you're always going back to that flour, which is always your 100%. So you're using that 14,151 and multiplying it by 25%, which is going to give you 3,538 if you round up. And then your salt, which here you have it at 2%. So 14,151 times 2% is 283. So this is all in grams. And so if you add all of that up, 14,151, 12,028, 3538, and 283, you get 30,000.
Wow.
So there you go.
Yeah.
So there is a lot of math.
There is.
But once you get the hang of it, it makes life so much easier.
And-
So
Go ahead.
I was just gonna say, here's some little facts with like comparing formulas easily. So imagine comparing different weights or volumes with percentages. Everything can be compared using a common language. You can also adjust formulas, create or adapt formulas, and scale formulas up and down with ease. You can take any given formula, recipe, and quickly identify with and predict the characteristics of the final product without having to do the baking first. So, for example, with the brioche loaf, you would look at the fat percentage would be like astronomically high. So you know that you would have a richer loaf. So it's really interesting to look at percentages in things and know automatically this is going to be sweet, this is going to be fattening, this will be this. So
There's a lot, and there's so much more we need to talk about. But we're going to send it back to the studio right now, and we'll be coming right back in just a little bit.
All right, thanks for that, Mary Lou and Laura, and we'll find out the final bit on all of that bread right there. We do have phone tutors available until 5:30. We've got Val in studio, and she's been hanging around, so time to do some more work. Here we go. Over to the board, young lady. So, Devin, if you would be so kind, 4 4s on the board, a little space in between each of them. Val, I would like you to select a number between 1 and 10.
5.
5. So we're going to make it all equal to 5. So here are the rules of the game. You need to use all 4 4s, Val. You can add, subtract, multiply, divide, group them, use any sort of mathematical symbols you like, but you need to use all 4 4s and make them equal to 5. So explain to Devin how you would like to do this.
Do you only get 4 4s?
These are the only 4s you are permitted to have to work with. Now, you can use any combination of operation symbols, add, subtract, multiply, divide. You can use all addition. I don't think that's going to get you to 5. You can use any combination of square root symbols, anything else in math that is a symbol, parentheses, grouping, anything. It could be a fraction. It's up to you. Play around with it, see what you can do with it.
You add these
So,
with basics. No, you subtract.
and right away you're seeing that, well, if I just add and multiply, I'm going to end up way beyond 5.
No, isn't this then?
So I think you're looking at ways of keeping the numbers smaller. And I noticed that you erased that 16 because you're looking at the multiplication. And that's making you think about, well, maybe these values are going to get a little too high. However, you did end up with a subtraction piece here. Now, if we were just to do standard order of operations, we'd have 16 minus 4 plus 4, which would be 16 minus 4, which is 12, but then we just add that 4 again. So that would just get us back to 16. Those grouping symbols might play a role to get us a little bit closer. So, what could we try that would allow grouping symbols to help us out?
We could try using parentheses.
Okay, where would you like to try to use parentheses here?
Around this.
Okay, so now when we subtract, we're not subtracting 4 anymore because what's inside the parentheses?
4 plus 4.
Which is what?
8.
8. So we'd have 16 minus 8. Well, that's 8.
Yeah.
But
so
it's closer to 5 than 16 was. So as long as we're getting closer, we're making progress. Maybe we can try using some other arrangement of the grouping symbols. So maybe instead of putting the grouping symbols there, where could we put them? Well, if we don't know, we can try, right?
Over there. Maybe?
Over here, are you saying around these two?
Maybe these.
Oh, these two here. That gives us an interesting scenario. 4 minus 4.
Is 0.
0. So now we have 4 times 0 plus 4. Which of that are we going to have to do first?
Multiplying.
So we'd have 4 times 0, which equals
0
plus 4.
would be 4.
Oh, so close. We're 1 away. We're 1 away. We need to find a way to either get 1 farther beyond a 4. Maybe the solution is a combination, or we just keep playing around with some of these operations and then bring the grouping symbols in. So, what else could we do with these 4s outside of the operations that we have here? By the way, there's nothing that says that you have to have them all in a straight line. As long as you have 4 4s, you can do anything you want with them.
I'm lost, honestly.
Oh, okay. Some of the things I've noticed, one clue is a form of division that people use to help them make sense of getting to play around with some of these values. Could we create some sort of fraction?
Oh.
Okay? Because if we have a fraction of 4 over 4, what is the value there?
1.
1. So we could do a lot of things with that 1, especially since we're 1 away from a 4. So we have some options to play around with. And by the way, this 5, oof, I really felt for you when you chose 5, because 5 is one of the tougher ones to really reach.
Right. And what I would do
setting.
is I would say, let's leave the multiplication at the beginning like you wanted to do.
Okay, so
So we're going to leave it at 4 times 4.
higher there.
Then you're going to do, and let's put your grouping symbol, let's put your parentheses around the beginning, the very first 4,
Okay.
and the third 4.
Oh, interesting.
And let's work from there.
Okay.
And I'll give you a moment.
Moments are always valuable. So he's led us with a lot of information here. We know that that multiplication is going to be very helpful, and we still have some more operations we can work with here to get to 5.
So you're only going to use addition and division now.
And that's really useful because if we think about the relationship between 5 and 4, what other values come into play, especially when we think about division? Fact families, where else do you see 4 and 5 together in division fact families?
Multiplied?
So if you multiply 5 and 4, that's going to get you to what?
20.
20. So we know maybe if we get something here that we can divide by 4, we can get to 5. Because we know 5 times 4, this is going to have to equal 20. Now we know we have 4 times 4 equaling 16. How could we get from 16 to 20 with just one operation right here? So, walk us through this just to make sure we're there. 4 times 4. We're going to do this parentheses first, right? We're not going to worry about this division yet. 4 times 4.
16.
Plus 4.
20.
So 20 divided by 4?
Equals 5.
I think, Val, that we've just done it.
Yay.
Wonderful work. Yay!
Indeed you have. Now, here comes your next challenge. You can leave that there. Erase the minus or equals 5 at the bottom.
Okay.
We'll leave what you've done already up there. That's one way to solve the problem to get to 5. Now what I'd like you to do is I'd like you to find another way to get to 5. But we're going to introduce a mathematical symbol, and I'm sure in 6th grade, Val has already seen this, a square root symbol.
Ooh.
So use a square root symbol and use 4 4s and get to 5 again.
Now, I don't know if the mics picked this up, but Val audibly exhaled, "Oh no," when she heard the square root symbol. You have interacted with the square root symbol before. What causes the "oh no" part?
It confuses me.
Oh no! Okay, so let's talk about square roots, right?
And you've got 3 minutes.
Oh boy. We know that we think about a square root. We're talking about the number that when you multiply by itself gets to the number inside here. So for example, the square root of 25. What number times itself equals 25?
5.
Yeah. That's all that that symbol represents. Some number times itself is going to equal what's under that bracket. Now, that's very helpful when it deals with 4s, because 4, as you may be familiar with, is a square number. So, what do we know about the square root of 4? What number times itself will equal 4? 2. So if we can get a square root bracket around a 4, we know we'll have a 2. Let's go ahead and get rid of some of these symbols and maybe play around with that, okay? If we put square root symbols on all these 4s and add them together, that's going to be too much, right? It's going to end up with an 8. If we multiply them together, we're going to have 2 times 2 times 2 times 2, or 2 to the 4th power, which would be 16. Again, too high. However, if we use 2 square root symbols, this is going to be really useful to use. Then, we'll have 2 other 4s that we can play around with to get us closer to where we need to be, which again, our goal is 5. So what are you thinking here with this, Val?
That you could use the other 4 to make a fraction.
Ooh, okay.
You can make
So
1 to get 5.
So that's going to be, oh, that's very interesting. Now, you said we can use this as a 1 to get to 5. So are we adding this to something that we're doing with these 2 square roots of 4?
Yeah.
What could we do with these 2 square roots of 4?
You could add them. Like, you'd get 2 for each of them.
Right.
And they're added to get 4, and then plus that would be 5.
So you could add them. 2 plus 2 is 4, plus 1 is 5. What would happen if we multiplied these?
Who knows? We don't know.
Who knows? We know. And we're going to find out right now. Let's change that up and see, right? The worst thing that happens, the worst thing that happens is this falls off the wall onto our feet and we have to go to the hospital. this won't be that. Let's try to multiply. The square root of 4, 2, times the square root of 4, 2. 2 times 2 equals
4
plus
1
equals
5.
So we could have used addition or multiplication here with this use of the square root symbols. Doesn't work all the time, but with 4s, it's very helpful.
There you go, nicely done. And for doing such great work
Yeah.
right there,
Someone's
we've got a couple of passes to any athletic event at CSUB. So congratulations on that. A lot of
watch
things
out.
going on, right? They've
Good moves. Oh, flag.
volleyball going on, basketball, wrestling's going to be coming up. Swimming seems like it
Wait,
goes
is
all
the wrestling
year
guy
round,
coming?
and
Like, do I have to dodge that now?
be ready.
Let's go. Ears.
All right, you know what? We have one more opportunity to find out more about the baking of bread.
We are back at the Boys and Girls Club on Niles Street, and I am with Laura and Ian Journey from Baker's Outpost. And we just finished up with a wonderful math problem and so much math involved in this. Can you kind of go a little bit more into the actual baking process and all that's involved? Because obviously when kids bake, they're just following this recipe, right? But it's not that simple.
Yeah, I think the thing with the bread that a lot of people don't understand is with it being naturally leavened, meaning that we're not using any commercial yeast that you would buy at, say, Vaughn's or Albertsons. We're harvesting yeast from the air, and so by the nature of using the natural ingredients, it typically takes about 24 to 48 hours from start to finish to make a loaf of bread. And a lot of that has to do with the ambient conditions, so weather, humidity, time of day. It just seems like there's a lot of variables that you have to be really adaptive, even though you're following a recipe. And it might have turned out, the bread might have turned out good yesterday. Now, especially this time of year with the weather changing, Laura, I think, is having to adapt her schedule, and I think things are moving a little slower. Things typically, kind of like in a lot of things in chemistry, heat tends to activate things, and that's true for wild bacteria.
Can you talk a little bit about the yeast, okay? Because some people don't really understand what the yeast is.
Yeah, so the yeast we call our mother. It's kind of like a third child for us that we have to feed and take care of. But what you're doing there is you're mixing typically about equal parts flour and water, and we put that in a warm place, so say like on top of your refrigerator, and you can actually harvest the yeast in the air by every day throwing away half of that amount and then replenishing it or feeding the starter. And over time, you'll start to see activity, you'll start to see bubbles, you'll start to see it grow and sink and really get in a rhythm. The really interesting thing is that San Francisco, you hear the term San Francisco sourdough, that's actually not really good marketing on their part. That's actually because there is a certain bacteria strain that is natural in the air up there that creates a really good sourdough, and that really particular sour flavor. So that was something interesting that I didn't know.
Your yeast, you were saying, how long have you had your yeast, your starter?
We've had it since we were in Vancouver, living up in Canada, about like 8-9 years ago. But I think we were talking about it earlier, and I mean, when you're throwing it away and replenishing it every day, those same bacteria that were in there 9 years ago are not in there. So it's been going a long time, but I don't think it has much to do with the final product.
Now, also your flour, you were saying that you have a special flour you use.
Yeah, we support the Tehachapi Grain Project up in Tehachapi. They're dear friends of ours and working really hard to regenerate the California grain economy. So they specialize in Abruzzi rye, red fife, and Sonora, and so that is what we tend to use a lot of.
Sonora and red fife are types of wheat specific that, like Laura was saying, they're drought tolerant. So that's really just trying to recreate the wheat industry in California, because I think we used to grow a lot of wheat, maybe 100 years ago or so, and so it's really fascinating. And going back to how we started the company too, they were big supporters of ours and us wanting to give back and share such beautiful product that's from our own backyard with the rest of the community.
So let's talk about your business. Where are you moving forward with your business right now?
We are going to be opening a small brick and mortar downtown taking a little bit of an extra longer time than we had anticipated. But we're really looking forward to being a part of the community, and they've opened us with big, wide open arms ever since we started dealing with the public. So we're really looking forward to it.
And what is your hours and your final goal for your product for that business?
We will be early mornings, catering to the early risers, the breakfast and early lunch. Community things on the weekends, just looking to being a part of engaging with other like-minded individuals who are focusing on nurturing their bodies with simple foods.
Out of everything that you bake, what is your favorite thing?
Ooh.
I would have to say her chocolate sourdough is, it's not only good, but it's also really unique. And you're not gonna, I don't think I've seen it anywhere else. And yeah, it's very good. They, even using it in like, we have friends that use it in kind of savory, like grilled cheese sandwich, because it's not very sweet. So it's a real subtle chocolate flavor, but it's very delicious.
Well, the best of luck to you guys, and a little token of our appreciation
Thank you.
for letting
Then I'll
us
have to go into
visit
our
with
new
you.
kitchen.
Oh, yay! Well,
Thank
again,
you so much.
thank you, and best luck to you. And I know the bread is wonderful because I've had some before. So again, thank you very much.
Thank you. Thank you for having us.
And that's it from the Boys and Girls Club with Ian and Laura Journey. Back to you at the studio.
All right, thanks for that, Mary Lou, and thank you also to Ian and Laura for giving us a little bit more insight into the baking of bread. Fine bread, I can tell you that once again. We do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. We would like to also thank Val for coming in this afternoon, a 6th grade student from Williams Elementary, a lifelong pioneer up to this point, but getting ready for all of the different events and things going on at junior high, right?
Yeah.
All right, well, you know what else is going to be exciting? You are now going to be an ambassador. Do you have any idea what that means?
No, not
Well,
really.
first of all, you're going to get a uniform. So here's your uniform. This is the uniform for being an ambassador for Do the Math. So all this means is that when you wear this shirt and people go, hey, what's up with that? All you have to do is tell them about Do the Math. Can you do that?
Yeah.
Then we'll
that's
say
an
that.
easy
Then
enough
we'll
job.
say, what's up with that?
Right?
Absolutely.
What's up with that?
Verbatim.
But anyway, we'd like to thank Val for coming in once again today. And do remember, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.